Hi all, I'm Mr. Mendoza, second grade teacher at Webb Du Bois Charter Academy. Today we'll be reading the third lesson on forces at work. Magnets. Those are some pretty powerful forces, but every magnet is different. There's a job for every magnet. What if a wrecking company wanted to pick up a car? Would they use just a regular old magnet? No, of course not. They would probably use some kind of an electromagnet where it uses electricity and other forces to be even more powerful. And that's how they pick up an entire car. What if refrigerators have magnets also? Those are also electromagnets. What if you just want to pick up a bunch of metals, a bunch of small paper clips or staples from the floor? You use a very small magnet. As a matter of fact, you can use a whiteboard marker that is magnetic to pick that up. And that doesn't have much of a force, but every job will use a specific size of magnet or power. So here we go. Magnets push, magnets pull. Why does a magnet pull some of these objects and not others? Think about it. Why does a magnet either push or pull certain objects? Why does a magnet pick things up? Why? What sticks to a magnet? A couple of things you'll need for a little experiment: string, pencil, magnet, small objects, any objects, and a paper bag. 1, tie a string to a pencil, tie a magnet to the end of the string. 2, put the objects in a bag. Which objects will stick to the magnet? 3, use a magnet to pull out objects from the bag. And 4, how are the things that stick to the magnet alike? Think about all the things that are stuck to your magnet and go with it. Vocabulary for this one: attract, pulls, and repel. Here's an example of a very big magnet used at some kind of a junkyard. A magnet can push and pull. This is called a magnetic force. A magnet can attract or pull objects made of iron. A magnet will not attract a penny because it is not made of iron. Is a quarter made of iron? How can you find out? If a quarter has any bit of iron in it, how can you find out if it does? Well, test it with a magnet. This machine uses a very large magnet to pick up large objects. Magnets can move things without even touching them. Magnets can pull through solids like paper, plastic, or glass. They can pull through liquids and gases too. Every magnet has a magnetic field. This is the area around a magnet where its force pulls. Here's a brass pot. These are all things that a magnet will not attract to these things. A magnet will not attract objects made of brass, gold, or aluminum. If you put a magnet towards these, it will not grab onto it because, again, magnets only attract iron or objects that have iron inside of them. Magnets can pull through liquids and solids. If you put something that is magnetic in a glass of water and put a magnet close to that cup of water, that magnetic object will pull towards the magnet. And you can also move it up and down. Will a magnet attract a rubber band? Will it? A rubber band. What are poles? Magnets have 2 poles, a north pole and a south pole. See the illustration? Just like our Earth, is a big, huge magnet also. It has a north pole and a south pole. Same thing with magnets. The poles are where the pull of the magnets is strongest. A magnet's pull is stronger on iron objects that are close than on objects that are farther away. The Earth has a magnetic field. It has two poles, a north pole and a south pole. Here's a magnetic field on magnets. This looks pretty cool here. That's why I had to blow it up here. Here's a magnet. The north end and the south end are both magnetic. And notice how most of the iron filaments around it are attracted to the north and south end. None really towards the middle. And that's where you see nothing being pulled towards it. The north and the south end are pulling iron filaments close to them. Where does this magnet attract the most iron? We just talked about that. I just mentioned to you. Look at it and think, where? The poles of these magnets attract each other because they are opposites. A north pole and a south pole pull toward each other. These in south and north attract. The poles of these magnets repel or push away from each other. They repel each other because they are the same. South end and the south end cannot come together because they have the same magnetic force. Just the same way as the north end and the north end, they can't because it has to be opposites. Which poles attract each other? This is something to think about, talk about, and write about. What will happen when you put foil near a magnet? Try it. See what happens. Is foil iron or does it have iron in it? Check it out. Try it. When will two magnets repel each other? When will two magnets repel each other? If you bring them together, but they don't want to stick. Why are they doing that? 3, write about how you can use magnets. Think about some different ways that you can use magnets. I already talked to you about it, but I want you to think more. And make a sculpture using magnets and objects. Imagine making a sculpture using magnets and objects. What would that look like? How can you compare the strengths of different magnets? One, here's a way that you'll compare the strength of different magnets if you have magnets that are different sizes. How can you compare the strengths of different magnets? Find out how many paper clips the magnets can attract. Hang a paper clip from a magnet. Keep adding more clips in a line until no more will stick. It's like this little boy right here is doing. He has a small magnet. He just keeps on attaching one magnet to the other. And they will stick eventually. If it's a very small magnet, obviously it won't hold very many paper clips. You have 3 different types of magnets here. A round one, a U-shaped, and a bar. When you do that with all 3 of them, you record the data. Right? How many paper clips can hang from the magnet? You can actually do a bar graph also. A bar graph telling you how many paper clips. And you can, or a picture graph demonstrating how many paper clips each magnet will hold. Repeat the steps using the different magnets and communicate or talk to somebody. Make a bar graph or a picture graph to show the strengths of your magnets. Talk about it. Stick 2 magnets together. How many paper clips can hang from them? Why do you think this happens? Try to put 2 of these together, or even 3. See if its magnetic force is stronger. Thank you for watching this video. I hope that you enjoyed it. I could have made it better, but I don't have any magnets with me. All my magnets are in the classroom.